My name is Suzanne Joaquin. I'm the Open Educational Resources Coordinator at Butte Community College in Northern California. I'm also the chair of the honors program, and I've been a biology faculty for well over 20 years. In that time, I have designed dozens of different courses at various levels and using various modalities. I've also worked with a number of different textbook publishers, both open and otherwise, on writing textbooks, instructor resources, student resources, standardized tests, and the like. What I wanted to do here is share a little bit of how I use open course design in various courses that I teach. And I'd like to begin with my journey into the Great Wide Open, because it was rather accidental and I really only learned the name of what I was doing a few years into the process. And so I think actually a lot of instructors are already using aspects of open pedagogy, and I wanted to discuss how those can be used in various different courses. So my journey began with kind of a problem I was having with Bloom's. So with Bloom's taxonomy, you're supposed to begin with the base of the pyramid with basic recall information, build that to understanding, build that to applications, and so on. However, in a single semester GE class where students coming in have almost no background in biology, I couldn't get much past the remember and understand phases. And that's a real problem, because I think what's important in general education is really to get students to that application and analysis of the information. So for example, in my field, I really want them to be able to go to a doctor, and if they have medical questions, to be able to research that and understand what all the information means. Or if they're at the polls and there's a scientific legislation that they're voting on, to be able to understand what that legislation means. And so, I felt it was really important to get them to understand all this information and be able to apply and analyze it. Whereas things like the kind of core recall, such as the structures of a cell or the steps of mitosis and so on, those are really things they can look up. And so what I started doing is I took away some of those terminologies and basic recall facts, and I filled them in with more application and analysis. So for example, instead of talking about cell structures, we talk about the difference between how antibacterials and antivirals work, and the difference between how we use antibiotics and how we use vaccines, and why those are very different discussions. And overall, I think that's been working really well. I actually really like that strategy, and I'm still using aspects of it in many of my courses. But the problem I was having with that is that I was still just teaching them knowledge rather than teaching them how to acquire knowledge. Right? So we spent a lot of time talking about the applications and the analysis, and I really wanted to focus more on having them learn about things, because in many of our fields, and in science for sure, the fields are moving so fast that what I'm teaching them now may not be relevant 10, 20 years from now, and what's really important 20 years from now, I can't necessarily know that, right? And so what I really want them to know is good information. And more importantly, when they're researching science, I want them to be wary consumers and not be taken in by misinformation, which, in the internet is a wonderful source of great information, but there's also a lot of misinformation out there, right? And, sometimes the misinformation is for humor, right? So The Onion, great satirical newspaper. But this site here is all about, people that take The Onion seriously and are taken in by that, and isn't it funny that they thought this was a real story? And to me, that's kind of a scary site more than it is a humor site. Sometimes the information is really more deliberate misinformation. But what was really concerning to me was studies like this one here, where they were looking at how many people were taken to the emergency room or went to the emergency room because of supplements, right? And the issue is people don't think of supplements as something they have to be concerned about because they're natural, because they're not drugs, right? And so that sort of misinformation, that sort of core misunderstanding is physically dangerous to the students. And so I really wanted to focus on more open learning strategies that focused on knowledge acquisition. And what I'm going to explain in this talk is really two very separate frameworks. The first is not for the faint of heart. It's a fairly big, complex framework that I'm using in my honors class. And it's one that works great in small, kind of dedicated student groups. So it might work well in majors classes. But for my larger, 50-person, 80-person GE classes, that strategy is not feasible. And so I'm also going to talk about how I've adapted that and used pieces of it for a much simpler approach of just replacing some assignments with more open with more open assignments. And so I'll kind of go back and forth between the two of those. I'll explain the larger framework as well as how I've adapted that to my more traditional GE courses. So the framework that I built really began with a collaborative project that I was working on. As I mentioned, I've written a few textbooks, and one of them was a collaborative textbook with instructors from all over the country. It was through Carnegie Mellon, their Open Learning Initiative, and it was a fabulous experience. It was just beautiful. We were working on Google Docs, and we'd have these really great discussions in the comments about, what's really important to put in this book. Is this information really essential? How should we present this information? Is it clear what we're talking about? Will students understand it? What's important? What are the applications of this? And as I was having these discussions, it really occurred to me, these are the questions I want my students to answer. This is what I want them to do. And so I started thinking, well, what if students did this? What if I had them write a book? Would they kind of come to the same discussions? And then I really started wondering, what would a book written by students look like? What would they put in? What would they think was important? And at that point, I was just kind of curious, and I thought, okay, well, let's see how this works. So, right away I knew there was going to be a couple of challenges. One is that writing a textbook is a huge endeavor. And there's no way this was going to happen in one semester with GE students. It's just not possible. And so I needed to take a multi-semester approach where students in each class build on the class before them. And so this meant that every semester is kind of an experiment, which is challenging for some people, but for me that was such an authentic learning approach, right? Because that's really what learning and science in particular, it's what it is. You try something out, and if it doesn't work, you learn and you move on, right? I mean, that's the beauty of learning in that sort of experimental way, rather than the approach of kind of marching towards the right answer. So that was one concern. The other concern for me was quality, right? Like I mentioned, there's a lot of misconceptions, and I didn't want to create a product that had a bunch of misconceptions. And so I've decided that's really my main role as the instructor, is to make sure it's all accurate. So other than that, the kind of fact-checking, I really gave the students a lot of latitude and had them design the book and kind of see what they wanted to do with it. Now, the one other kind of limiter is that our courses have learning objectives or learning outcomes, right? So there's these list of things that students have to learn from the class. And so I can't just, let them run amok in the wonderful world of biology. I have to guide it a little bit. And also I have to be able to measure if they've learned the information. So what I did is I designed very specific study guides with very specific questions. And I also use the same test in this course that I do in my other courses, just so I can compare the two and know how well the students are learning with this structure. And what I found is that overall the students are learning just as well. So I have not seen, now it's a very small sample size, but I have not seen any significant increase in learning, but I have seen incredible increases in excitement. So, students are just loving this type of course. These are some of the bits of feedback I got from students, right? So the first one is really talking about how excited they are to be creating a free textbook, because, the cost of textbooks is problematic for a lot of students, and they kind of feel taken in by the system of having to spend so much. And so to kind of, fight the power, as it were, they really enjoy that sort of empowerment, right? And other than that, they really enjoy it. They want to come back. I've had a number of students say, can I take the class again, just audit it, because I want to keep working on it. I've also had students create additional aspects to the book as part of other courses that they're taking. So there's some project for another course, and they weave those together because they're really excited to participate in the product. And so in addition to just kind of being exciting and fun, I think what's really struck me as maybe not the thing I expected was how powerful it was to kind of empower students to create these learning materials, right? So they're kind of used to, especially at the community college, right? They're used to just being passive learners. They don't feel like they're academics. They don't feel like they're intellectuals. And here I'm telling them, you know what, you're going to write a textbook. And they really grow with that. They really start understanding that, yes, they can be part of the academic discourse. And so, finally, one of the things I really like is that this is kind of beyond authentic. It's real, right? So I always thought about our heavy equipment classes that build stuff, and I was kind of jealous because they actually build these beautiful things that people use. And now we get to do that in my biology class. So this kind of larger course design is, I took a sabbatical and I developed this little website just kind of explaining how this course design works in case anyone's interested. And what's on this Google site is kind of the overall approach and a little bit about what I've learned along the way, how I've structured the assignments, examples, so that if someone comes in and wants to do this, they have kind of everything they need, and they also have, a little bit of cautionary tales, right? Because like I said, every semester is an experiment, so I'm always learning, which, by the way, the students love, right? They really buy into this, that we're all doing this together, we're all learning together. So that's the larger approach, and I should mention I'm really only 2 semesters in right now, and I only teach the class once a year, so this is going to take many years. But it's, the point is not really so much to actually create this book, but it's the process of building the book that I'm most excited about. And so as I go through the process year after year, this will all be updated with, what I've learned along the way. So in starting the process, right, any good writing project starts with an outline. And that was really the first thing we did. In my first semester, I had the students look at multiple textbooks and come up with an outline. So I divided them into groups, and I gave each group kind of a broad topic, right? So your topic is DNA or community ecology or whatever it might be. Look through a bunch of different books and come up with an outline. And to make sure, so my concern with this step was I didn't want them just going through one book and creating an outline just like the book, because that defeats the purpose of a student-created product. And so I had them also write a justification of why they created the outline the way they did. And that to me was originally just to kind of to avoid cheating, as it were. But really in the end, that was the most powerful part of the discussion. Students really got into, why did I include it this way? Why, can I cover that topic in my unit? It makes more sense. Do you want to cover this topic in your unit? So they were really having these wonderful discussions of how information connects. Right, and as we all know, when you start making those connections, the learning is solidified. So, in addition to the outline, because remember, this is my main learning strategy for the course. So, instead of lecturing, instead of giving them videos to watch, this is how they're learning the information that they'll be tested on later. So, I really wanted to beef this up enough so that they were thoroughly learning the information. So I also had them create a list of important terms and definitions, because we biologists love our terms, and so that's an important part of many textbooks, so I had them do that. And then it started feeling like they were maybe going to get too bogged down in the details, so I also had them look at the hook and conclusion. Right? Those are the pages at the front and end of a chapter where they talk about the interesting applications of this, right? So I wanted to give these students a chance to think about the interesting applications. And for that, I had them just kind of rough out, what application would you include. And finally, I had them write quiz questions. Now, that's something I do actually in all of my classes regardless, because I think it's a really great learning tool to get students to think about how they're going to be assessed on information. And I have them actually write multiple choice because I want them to really think about what sorts of things can confuse me. What are 3 other terms that I might confuse this term with? It also builds up my testing pool, right, which is lovely. So I have almost infinite questions, and it's surprising how great the students' questions are. Some of them are kind of baseline, and there's a lot of repetition, but they come up with some really wonderful, wonderful questions. And so I've been using a lot of those. Now, in this unit, and this is true for all the parts of this every semester for this course, the students have to learn everything, right? Not just the little piece that they're outlining. And so I have them comment on all of the outlines, so they're looking at all of the information. And then the original group uses those comments to refine their final outline. So that was the first semester. And the way I apply this to my larger traditional GE courses, right, the way to take this and really simplify it into a single assignment is to have students do something like, outline the book, right? That's pretty common. It's not news, right? But the way I've changed this up a little bit is I give them a choice of how they create this outline. So they can create a traditional outline. They create, mind maps, which is this here. They can create flowcharts or tables or flashcards or really whatever it is they want. And so the way I set up the assignment, just one of the example assignments that I use is in our macromolecules section, which is a kind of a standard topic that you cover in biology. It's essentially a list of 4 main groups and examples of chemicals in each group. And what the students need to learn is how the chemicals are grouped, so what goes in each of the 4 groups, and what is each of the chemicals, how are they different. And so, what I do is I give them all the chemicals and I say, show me that you understand what these are and how they're connected. And then they can do that in any way that they want. Early in the semester, I give them a list of options. So I tell them, you can create a mind map, you can create an outline, you can make flashcards. And then later and later in the semester, they start understanding that they can kind of, however this makes sense to them, that's how they can show me that they understand it. And so some of the examples of what students have done with that assignment, you can see at the top there is kind of a standard outline with definitions, fairly simple. Down below, a little table. On the right there, flowcharts, mind maps. And so students kind of do whatever they like with it. What was really interesting, though, is students really started having these discussions about, well, what did you do? Did that work better? I just made a table. I don't know if that was really the best way to do this. And so they really started thinking about how they're learning the material. And again, it kind of empowers them to try things, to say, what, this table was the easiest thing, but did I learn it well? Am I going to do well on the test? And actually, one of the things I'm going to add is I'm going to require that discussion. So I'm going to ask them to look at what other people are doing, compare and contrast, think about what might be more or less effective in the different strategies. That was actually surprisingly powerful, and it was something the students came up with. I actually didn't plan that at all. A few other examples that students came up with, right? There's flashcards. There's also online flashcard tools. And at the end of the talk, I'm going to show you a list of where you can find all of these online resources. Because what I did is I created a list of all these different resources that students can use to create their demonstration of knowledge. And in the end, what I've discovered, what's really wonderful about this aspect of open pedagogy is it gives students a choice. Right, so the map at the bottom is you're getting from point A to point B, and you have 3 different routes, and they'll all get you there. Some are a little longer, some may be more scenic or whatever it might be, but as long as you get to point B, how you get there, it doesn't matter to me, as long as it's something that works for you and is actually helping you learn. And I've also discovered this is kind of an equity issue as well. So some students just don't do well with with paragraphs or with outlines or with mind maps. I actually don't particularly care for mind maps. I'm a visual learner, and so that assignment would not work for me in that way. Whereas for a lot of students, they love them because they're kind of they're more visual like that, whereas I'm more linear. And so it really helps students demonstrate the knowledge using their strengths, which for many underrepresented groups is not something they get to do often. And for me, what's been powerful about this is it really helps me focus on what exactly do I want students to know. So kind of step back about what is the assignment and how am I building this kind of neat little project. And I just tell them what I want them to know, and they build the project. So it's been very interesting. So that's the kind of step one. Step two, so back to the more complex framework, is having students create a list of samples and sources for the book. So we created an outline last semester, and in between I took the outline and I cleaned it up. So again, my role is finding misconceptions or errors and cleaning all that up. And rather than just having students jump into the writing, what I wanted them to do is find examples of good writing for the next group. And actually part of the reason for that was one of my experiences with a couple of different writing projects where what I found is even with instructors who teach very similar classes, if you give each of us a chapter and just say go write it, you're not going to hit consistency very well. It's going to be too variable. Whereas in another project that I worked on, what they did is they had one person write an outline of, here's what you have to cover, don't go beyond this level of detail, but be sure to go past this level of detail. So kind of these limits, which as a writer was actually quite challenging, but also a really great experience and really created a much better product. So I wanted to do that for my students, both give them that experience and also create a good product in the end. So what I had them do in this particular case is they reviewed the textbook. So they listed the textbook, what did they like, what didn't they like, what was good about the approach. And they did the same thing for 5 online sources. And what was nice about that is it showed them different ways to approach a topic, which again for learning, right, that's the whole point. For learning is really great because you're seeing 5 different ways to explain the same thing. So that's a nice deep level of learning. It also gave us a great excuse to talk about reliable resources. So I required that whatever resources they were using had to be reliable. And that was, again, one of those surprises where that was surprisingly important. Students really didn't have a good grasp on what are reliable resources to use. And we had some wonderful discussions. And for that reason alone, I almost wish I could just do this particular step over and over again. In addition to the online sources, I had them create instructions for the writer, so that list of what the writer should include, and to find 3 usable images. And again, this was one of those ancillary useful tidbits where we got to talk about copyright. You can find all sorts of great images, but they're not necessarily usable, right? And that's of course one of the problems our students have with plagiarism, right? You can get anything online. But what of it are you allowed to use, right? And so we had some really great discussions about copyright and proper citations and so on. And again, I had them add to the quiz bank. So the way I apply that to my more traditional GE class is, again, focusing really on online resources here. So in my particular courses, I have lists of resources that I think will help students. They're YouTube videos, they're NIH sites, they're different textbooks, they're all sorts of things. And currently they're listed by what I like best. And what I'm starting to do is have students first summarize the information in that resource. And more specifically, this actually came out from something a student recommended, is specifically list which study guide question that resource addresses, right? So this video is really great for helping you with question 5 in the study guide, which I thought was a brilliant idea, so I'm going to add that in. Now the problem I'm having, what I want to do is I want to create these kind of Amazon-style ranking systems, right, where students can rate the resource and then write a little bit of a summary, but I haven't found a tool that does that. So on the left is Google's tool where you can click +1, right? But that requires a Google login, which I'm never really comfortable forcing students to create additional logins other than for the college. The other resource on the right there, same thing, requires a login. It's free, but still. So I just really haven't found a good resource for this. Currently what I'm doing is kind of doing that by hand, so having students comment on the resources, and I'm still trying to figure out exactly how to present that information. So that's a task for the future, right? But one of the other aspects to this is the list of resources that I give my students, and this is in the more traditional GE classes, is instead of telling them everything you need is in chapter 3 of the book, I give them a lot of different resources to work with. So I give them choice in how they learn the material, not just in how they present their knowledge. And again, that idea of choice has been really powerful for students. And so some of the benefits and the reasons I went to that approach is, life doesn't come with a textbook. And so it just always seemed, a little odd to me to say, this week we're learning everything in chapter 1, next week we're learning everything in chapter 2. There's advantages to that, but when they're out in the world, when the doctor says, you have this condition, you got to figure it out, they're not going to get chapter 3. So I really wanted to help them learn how to find information online. I found it also really helps students learn from multiple formats. And so if the way the book explains it doesn't work, then there's videos. If that doesn't work, then there's another tool. Then if that doesn't work. And that's really been great for struggling students, because they can kind of work their way down the list until it clicks. Meanwhile, asking me questions, of course. But there's not just the one resource that they have to understand. And again, it empowers students. This is what you need to know. I give them their study guide with the questions. This is what you need to learn. Here's all the different ways you can learn it. Find one that works for you. And when I ask them about this, what resource did you pick? Why did you pick it? How did it work? I find that they really enjoy that. They pick resources that work for them for very good reasons. They like certain ones because it's more interactive, and then other students say the interactivity is too much for me. I like just the text and pictures. It's more easier to follow. And so they're starting to learn how they learn best, which is really important. The only drawback is for some students it's a little bit overwhelming to have all of this list. And honestly, I thought that would be more of a problem, but I really only have about 1 to 2% of the students that have ever said that that's harder for them than just the textbook. So 98% like it better. But for those 2%, I think the summarizing what each resource does and connecting it specifically to a study guide question will be very helpful. So that's the samples and sources. For next semester, so I haven't done this yet, but for next semester I'm going to have their students actually start writing the book. So I'm going to take the samples and sources, take the outline, create a kind of format where I break each topic down into smaller bits with the samples, and then I create a task list for each topic, right? So for example, if their topic was structure of DNA, there'd be a list of samples that explain that really well, and then I'd have a list. So we need a paragraph, we probably need a picture of what DNA looks like, and then there might be some other options depending on the topic, right? So there may be diagrams of how does transcription happen. So that may be more of a diagram. Infographics are just kind of fun, and I think students learn well with that. So there may be some opportunities for infographics or summarizing tables or even comics, because there's a lot of really great way to present information, and humor is a good one. So I'm going to have this list of tasks, and students will pick which task they feel most comfortable doing. Now, the issue I'm already foreseeing is how to break these up into equal-sized chunks. And I don't think it'll be that hard, but I really need to think about, is writing a paragraph going to be as difficult as drawing a picture, right? And so there's going to be a couple of ways to sort that. One is to combine tasks. So write a paragraph and find a Creative Commons image, right, if it's feeling too small. Or I may divide it up into larger chunks. So write a paragraph on both DNA and on RNA, right? And so I don't think it'll be terribly hard, but that's the one thing that I need to kind of work out with this. So for the smaller approach to this is what I call community service. So like I said, you can find anything online, but what you find may or may not be useful. right? And so one example here is, Yahoo Answers, and I looked up what is global warming, and here, here's the best answer, right? And essentially it says, I highlighted it down at the bottom, essentially it says, don't worry about it. Next time someone talks about it, just ignore them, which is at the very least not an answer to that question, right? The question is, what is it? And so what I want them to see here is, not everything you find online is accurate. But what I have my students do is answer these questions. So you can go into Yahoo Answers and answer questions like anybody else can, right? And again, that empowers them to be part of the producers of knowledge rather than just passive consumers. I also have students draw things. So certain things are just easier in pictures than with words. And I've been saving some of the better ones and using them in a class repository, but I'm actually thinking of having them giving them the option of uploading their images to Wikimedia, because why not? There's some beautiful images these students create. Why not share them with the world? And of course, I'd never require it, but I think a lot of students just don't know that that's an option, that they can actually contribute in that way. I do know for the course repository that I've created, whenever I pick a student's topic or a student's project that's really good, they're so proud, right? So again, community college students are so rarely told that they are academics, they're intellectuals, and so they just, they really thrive with that. Now for the drawing programs, for the drawing projects, not all students are artists. I certainly am not, and the students are forever amused by my drawings on the board. But there's all sorts of online tools, right? So that's another aspect of this. And again, I'll show you all these links at the very end. But they don't have to know how to draw. There's free online tools for that. So after the writing, a few more steps, because again, I want to teach this class forever, so I need to see how I can expand this to useful resources for students. So step 4 is editing, pretty straightforward, just kind of cleaning things up, but also fact checking. Fact checking came from, again, another one of the projects I've worked on where we had to cite just about everything, even things that were common knowledge or things that you'd find in all the textbooks. And it was kind of eye-opening how often the textbooks miss new research, and how there's these little bits of misinformation that get wound up in the textbooks and carried through because people don't fact check as they create their books. And so I want to give my students the opportunity to look things up and find out, is this information still true, right? Science is always changing. We're always learning new things. And then past that is going to be the more fun kind of creating study tools, flashcards and games and all this sort of thing. Now that's really easy to apply for smaller assignments for the more traditional GE class, right? So I have them create flashcards. There's all sorts of game creation tools online. Purpose Games is one that I like because you can upload images, which for science is useful, and you can have kind of hotspot games. So there's all sorts of really great things online. And after that, the last 2 steps that I've come up with is step 6 is assessments, right? So like I said, students throughout throughout this project have been creating quiz banks. And what this group of students will do is take those multiple choice questions and develop feedback. And again, this came from a project that I was working on where we had to create very specific feedback for each wrong answer in a quiz. And it's a really wonderful way to really think about how come a student might have come to this conclusion and how do I get them to the right answer. And I think that can be really powerful for students to think about. I'm actually thinking of having students create that feedback much earlier in the process. So step 6 may, in the end, kind of go away if I have all students create feedback, because I think it's a really powerful approach to learning the information. And then past that, we have a world of multimedia that we can always create. And that, again, for the smaller projects for the traditional GE classes is pretty straightforward, right? So we can have them create videos, which nowadays everybody can do on their phone, and upload to YouTube, or have them create little lessons. So this particular site here is meant for teachers, right, to create lesson plans, but why not have students do that? Again, they can do this, and empowering them to do that is a really great way to get them excited about their learning. So as I mentioned, as I was going through all this process, I kept finding these wonderful online tools to help students learn. And this is an image, I borrowed the attributions at the bottom, and what I like about it is it shows there's just this whole world of wonderful tools online. And the problem, though, that I ran into is I couldn't find a place to where these were rated. So for example, mind maps, right? I found dozens and dozens of different mind mapping tools, and they were all free. Well, actually, it wasn't dozens and dozens, but it was quite a few. It felt like it went on and on. And they were all free, and they all looked pretty good, but I don't really have time to go through every single one of those and look for advantages and disadvantages. And so what I did is I created this site here. It's called RULA, Review of Online Learning Aids. Right? After a certain number of decades in academia, you can only think in acronyms, and so that seemed appropriate. And what I did in this site is I listed and linked to all the tools that seemed pretty good to me. And again, I didn't have time to play with all of them, but my hope is that as a community, we can all get together and look at these tools and talk and work together, collaborate, to find the ones that work best for our students. And so there's all sorts of different tools on here. This is an example of some of the drawing tools. This site is still pretty bare bones because I'm mostly just doing this to start the discussion about tools. If you have ideas on how to develop this, if you want to take all this information and build a better site, by all means. This is all open, public domain. And my email is down at the bottom. If you'd like to chat and collaborate, I'd love to work with somebody on developing a really great resource for instructors who want to use open pedagogy to collaborate and work together on how to do that. Thank you very much, and I hope to hear from you. If you have any questions, my email is right there. Thank you.